Okay, so here's the plan. The plan is we use our lake model, okay, and we have a steady state circulation in this lake, which no longer changes. And then we release a patch of tracer. And this is shown here as one example. So what we do is, in this area here where there's this little square, we prescribe a concentration of 1 or 100%, and everywhere else the concentration is 0. And then we start the simulation, and what's shown here are the outputs after 3 hours, 6 hours, and 9 hours of this simulation. Okay, so you can, for example, see after 3 hours. Okay, so after 3 hours, these are contours, these lines. What a contour is, it has the same value along these lines, but you can see that there are many of these lines. So this initial patch, which was a square patch, has actually become a patch where the highest concentration is in the center, and then the concentration decreases away from the center. Okay? So now the concentration that you have in the center is actually given here in the top, and it says 41%. Okay, so the initial concentration, which was 100%, after 3 hours already dropped to 41%. Okay? And then you can see what happens afterward. You can see that the patch moves. So after 6 hours, it's located down here in this lake. Okay? And then after 9 hours, it sort of disintegrates into not really two patches, but you can see it disperse. Only 15% within the maximum. So this is the upstream scheme. Okay, and as I said, it's highly diffusive. So that decrease that you can see is actually mainly an artificial effect. It does not reflect reality. And this effect we call numerical diffusion. All right, and I want to show you the simulation, that you can see the full simulation, and it comes on the next slide. Here we go. Okay, so at the end, after 18 hours of simulation, you find a highly diluted system where your tracer or your pollutant is actually distributed over most of your lake, and you have only one patch where you have only 7% of the initial concentration. So this was the first example. This is the upstream scheme without any corrections. So let's have a look at some of the TVD affection schemes that you can implement in your model.